Welcome to OGU's Training. OGU's is an integrated training platform for process engineering and upstream oil and gas sector. During process design we often have to decide number of standby equipment as 1 running 1 standby, 2 running 1 standby, 2 into 100%, 2 into 50%, or 3 into 50%, etc. What are the main considerations when choosing how many of each piece of equipment to specify and how many to operate or put on standby? We are talking about rotating equipment like pumps, blowers, compressors, as well as static equipment like heat exchangers, filters, dryers, etc. The major deciding factors for choice of the number of standby equipment are equipment cost, desired reliability which is decided by the criticality of the process, required turndown ratio, any special requirement by the process or operations, and also the maintenance duration of the equipment. We will discuss all these factors separately, with help of case studies. The capital cost of installing each piece of equipment often decides how many equipment will be installed, provided all other factors are taken care of. The capital cost here is not only the cost for buying the equipment only, but also the costs of the additional instruments and piping, valves, control system, cabling, installation and commissioning. Often the incremental capital cost per equipment and the incremental return on the project per additional equipment are plotted on an interest, project mix graph, and the break-even point is the intersection of the two lines, which shows the optimal number of equipment on the basis of optimum capital cost and the best return on investment. Often the number of standby equipment and the sparing philosophy, which means how many equipment to run at a time or how often to change over, depends on the desired level of reliability of the system. For example, the instrument air system of a plant is very critical to uninterrupted running of the plant, so it is good engineering practice to have 2 into 100% of all equipment like compressors, fans, filters and dryers. The two compressors are often kept loaded together, so that in case one trips the other one can immediately come to full load. Fire water pumping system is a safety critical system of a plant, so often the pumps are 3 into 100%, so that even when one is taken for maintenance and another becomes unavailable due to any reason, possibly fire, the other pump can take the full load. Mostly the pumping system has a jockey pump or smaller pump also which keeps the system pressurized while the bigger pumps are in auto standby mode. Gas turbine power generators are invariably 2 into 100% and the changeover schedule is often automatic with a view to evenly distribute the running hours between the two equipment. Often the anticipated turndown ratio of the plant determines the number of standby equipment to be considered. A plant catering to seasonal demand may need to have flexible turndown capacity and so more standby equipment will be required. For example, an oxygen plant supplying gas to a steel plant blast furnace may need to have wide turndown ratio and thus may have standby for its main equipment like the feed and booster air compressors, refrigeration plant, etc. Sometimes, special process requirement dictate the number of standby equipment in operation. Consider a temperature swing adsorption dryer system where all 3 dryers are capable of handling full 100% flow. One dryer will be in adsorption mode, one in regeneration mode and the other in cooling mode. So we shall have 3 into 100% equipment which will be periodically in operation. For another example, consider the nutshell filter system oftentimes used in produced water treatment for oil and gas industries. The filters need to be backwashed for generation at a certain frequency, so often the designer provides 3 into 50% filters so that backwash of one filter can be done without compromising the plant capacity, with a 33% or 66% turndown ratio. It may sometimes become uneconomical to keep the plant down for days together for maintenance, so often 2 into 50% standby is provided for those equipment which take long time for maintenance. For example, natural gas processing plants often supply to power plants and the supply is critical. Prolonged shutdown may result in disruption in power grid and resulting penalties. So the process gas compressors are mostly in 2 into 50% or 3 into 50% configuration, providing for uninterrupted operation during maintenance of one unit. The changeover is often automatically scheduled by the control system so that the running hours can be evenly distributed among all the units. We hope you liked this video. Do leave your comments and subscribe to our channel for more such informative videos.